Welcome once again to my YouTube channel. Feel free to click the subscription button and turn on the notification bell as I release more educative content and so on. And thank you and God bless you as you do so. So based on the topic we have started already, so we want to discuss on the rules of differentiation. We have three rules. One of them is showing on the screen there, right there. First one, which is that one there, is chain rule. Second one, we have quotient and product rule, but I'm going to discuss each of them one after the other. So we are going to first of all consider chain rule. So now, for instance, we have given that y is equal to u and u is equal to x. So what this thing entails is that y is a function of u and u is a function of s. So how can I now get dy over the s? Because my interest is not dy over the u or the u over the s. So we now have for the first one, which is, let me call here equation 1, equation 2. So from equation 1 we have dy over du because it's a function of u. So now y the second one, we are going to have du over dx. So now for us to get dy over the x, that means dy over the x will be equivalent to dy over du times du over dx. So now in this case, now for you to get your dy over the x, the multiplication of value you get here with the differential you get here with the differential you get from the second equation. So that's what this chain rule is all about. So it's the combination of differentiating one parameter with respect to the other, why that same parameter is a function of another function with respect to another variable. Like you are seeing now, y is an expression with respect to u, while u is now the same u here is expression with respect to s. So there's a relationship between the two expressions. So you can differentiate this one with respect to u and differentiate u with respect to s. With that, you can now get what you are interested in, which is dy over dx. Our interest is not dy over du or du over ds. Our interest is dy over ds. So by multiplying the two, so how is it possible? Looking at this, you know that if you cancel out now, du is at the upper here, so it can go remaining this one. So that is equivalent to this. But for the sake of when we are solving, we don't need to cancel. We need to get the value for dy over du and the value for du over ds and multiply it, and the answer we get there is now the value for dy over dx. Okay, let's solve this example here. The equation says find the derivative of each of the following. Y is equals to 1 in bracket 3x squared minus 2 raised to power 3. Y, and the second one is y is equal to 5 all over 6 all in bracket 6 minus x squared raised to power 3. And the question that will be running into your mind is that how will I know when to use this function or function? So when you look at those two examples, they notice that each of them contains a function in the bracket which is raised to power. So whenever you see a function that is a multiple or triple of that same function, rather than you expanding them, apply the chain rule or function of function for easy simplification. Because if you expand this now, this one will be 3x squared minus 2 times 3x squared minus 2 into 3 times or 3 aspects of it. And if before you start to expand it, it will take a longer process. So for the sake of that, another rule was derived, which will help you to get the answer so easily. And that rule is now chain rule. So that's when you know when to apply. Whenever you see anything, any function in person, because 3x minus raised to power 2 minus 2 is a separate function on its own. You can differentiate it separately. It's now raised to a power of 3, meaning that it's multiplied 3 times. That is, it's multiplied, yes, it's raised to power 3 and all that. So in this case now, you're not going to multiply that 3 times, that same function. Rather, you apply what we call chain rule for easy simplification. It helps you to get the answer without much stress or without any mistake. So we are going to start with a, which is y is equal to 3x squared minus 2 raised to power 3. So first of all, let's that function here, you call it u, equals to 3x squared minus 2. Then du over dx will give me 6x, because differentiating this one is 0. So now that y, okay, du over the s will be equal to 6x. Then y will now be equal to u raised to power 3. Then dy over du will be equals to 3u square. So according to chain rule, we now have dy over dx will give me dy over du times du over dx, and each of them has a value. So we now have dy over dx is equals to my dy over du will give me 3u square according to what I have gotten, times du over dx gave me 6x. So multiplying the two, we have dy over dx is equals to 6 times 18xu square. So dy over dx is equals to 18x. U has a value. Remember that I called it 3x square minus 2. And I have 3x square minus 2, then all square, another. So that is the value for the answer. Okay, for the second one now, we now do let u, the same procedure, equals to 6 minus x square. Du over dx will be equals to, differentiating this one is 0. So minus is at the back, it will still be minus 2x. Then remember that y will now be equal to 5 over u raised to power 3, which is the same thing as 5 times 1 over u raised to power 3. So y will be equal to 5 u raised to power minus 3 because of this 1 over here. So now dy over du will be minus 3 times 5 u raised to power minus 3 minus 1 will give you minus 4. So it will give you minus 15 u raised to power minus 4. Now dy over dx will give you dy over du times du over dx, which will now give us dy over dx will be dy over du, which is minus 15 u raised to power minus 4 times du times du over ds, which is minus 2x. So if you multiply, it will give you minus minus is plus, it will give you 30x u raised to power minus 4, which is equal to 30x. U has a value. What the value of u is 6 minus x squared. 6 minus x squared raised to power minus 4, which is the same thing as 30x times 1 over 6 minus x squared raised to power 4. That's your answer.